and from there and some other information about IP address. So when you hear us talk about prefix length, what are we talking about? You see, sometimes you see an IP address like this, 192.168.1.0/24. Oh, I didn't mute you guys. I need to do that. So sometimes you see something like this, 192.168.1.0/24. What is the meaning of this /24? Or you see 150.100.0.0/16, or you see this 16, you see something like the 10.0.0.0/8. What is the meaning of this? This is what we call prefix length. It is just pointing to the subnet mask. For this /24, it means what? This is class C. If you convert this to binary, this is 8 bits, 8 bits, 8 bits. 8 times 3 will give you 24. For class B, 8 bits, 8 bits, 8 plus 8 will give you 16. And for class A, it's only 8 bits. So this slash is just a way for you to know that we are still dealing with the default subnet mask. Mark my word there, default subnet mask. Because we are going to come to another class where you are not going to see the default subnet mask. You are not going to see /8 or 16 or 24. You possibly will see something like maybe /10 or /20 or /18, just in between. Why? Because that IP address has been subnetted, and that is what we want to do in our next class next week. That is, in our next class. That will be on Friday when we are going to learn how to subnet. So the reason for putting that slash is to let people know that we have not subnetted this IP address. We are dealing with this by default as it is. And if you don't put that slash for me, I cannot answer some questions. For instance, some of the questions I asked you guys today now, is it a host address? Is it a broadcast address? If you already know what I'm talking about now, you will not answer those questions. You will ask me for that slash first. You will ask me for the prefix length before you finally answer that question. But we're going to come to that. So anytime you see an IP address with those slash, it's just pointing to the subnet mask. So let me quickly move to the next part. So I've talked about all those host address, network address, and broadcast address, and we have done our own calculation. Whenever you see an IP address, you must be able to answer all of those questions. Another part we need to talk about is unicast address. Unicast is one-to-one, just like what we had in under MAC address. Unicast is one-to-one communication, while multicast is one-to-group of, broadcast is one to everybody. The same way we have something like that under my MAC address, we also have it under my IP address. So you could have a unicast address, meaning it's a one-to-one communication. You could have a broadcast address. It's an address that can be used to reach everybody. And you could also have a multicast address, which is an address that can be used to reach a group of people. Multicast is to a group of people. Broadcast is to everybody. Broadcast is to everybody. Multicast is to a group of people, not everybody. And there are some addresses like that. Any address you see with 224, that's the part I didn't get to. I'm going to show you guys later. It's class D. It's in D. It is a multicast. We don't use that. Because routers, switches, they use this kind of address to communicate between themselves. They use different multicast addresses. Different protocols use different multicast addresses to talk to themselves, to talk between to talk to themselves, you know. So we don't use all of this, but you still need to know that these are things that are available out there. So that is that on down. So this is another part I was trying to talk about. We've not finished that our journey. This one here, you must be able to answer these two questions as well before I can tell you that we're done with this journey today, or almost done. So I'm going to say it again now. Whenever you see an IP address, guys, you must be able to tell me whether it is a public IP address or a private IP address. You say this guy don't come again. Yes, we have not finished this journey. Whenever you see, this is not about class now, or network portion or host portion, whatever. You must be able to tell whether it is a public IP address or private IP address. So what is the difference between the two? When we browse the internet, it is only public IP addresses that can browse the internet. Private IP addresses cannot browse the internet, guys. They can only be used locally. Our public IP addresses are called routable addresses, or they are globally routed between different service providers. It's only public that can go out. Private cannot go out. Look at it here again. Private addresses are not routable. Private addresses are not routable. Don't forget, private IP addresses are not routed. They are used locally within an organization. When you want to go out, you can't browse with it. So the question is, how come you are browsing, even when you have a private IP address? Well, I'm going to come to that today before we finish today. So now, in class A, guys, back to our analysis. The only private IP address in class A is 10.0.0.0/8. The only private IP address in class A is 10.0.0/8. So it therefore means all other IP addresses that I showed you guys in that range in class A, they are public IP addresses. Somebody somewhere is using those addresses on the internet. So if you want to build your local area network, you are only allowed or advised to use this private IP address if you want to use class A. Any IP address anywhere in the world that is 10.anything.anything/anything is a private IP address. It's being used locally. It cannot go on the internet. So you just remove 10.0.0/8. All other addresses in class A are public IP addresses. I'm going somewhere again. In class B, we have more than one block given for class B. In class B, 172.16, 172.17, 172.18, 172.19, all the way to 172.31. All those addresses, 16 to 31, 172.16 to 172.31. These are the only private IP addresses in class B. All other addresses in class B are public IP addresses being used on the internet. And guess what? In class C, 192.168. That is why this is very popular. That is what people use a lot. Anywhere you see 192.168, it doesn't matter .anything/anything. It makes no difference. 192.168 is the only private IP address in class C. The rest are public IP addresses. This is another thing you need to commit to us. So if I go online right now and go and ping Google, ping Yahoo, ping Facebook, whatever, you are going to see that they will all be replying with public IP addresses. Ping www. I hope you will not. Okay, I will change this. Oh, it's replying me with IPv6. Let me force it to reply with IPv4. Ping, I think it's -4 www. Okay, so I'm forcing Google now to reply me with IPv4. Look at this IP address right now. From what I told you right now, this is a class C IP address, and it is a public IP address. I'm not talking network portion now. We can talk about that as well. What makes this public? Because this is class C, and the only private in class C is 192.168.anything.anything. Once I see 192.168, it's a private IP address. It's not useful on the internet. Let me ping Facebook. Ping www.facebook.com. Oh, it's also replying with IPv6. So let me change it. Okay, Facebook is replying me with an IPv4 address. Look at the IPv4 address that Facebook replied me with. They have plenty. They have plenty. Different servers all around the world. Look at this right now. This is class A. 102 is class A. It is a public IP address. What makes it public? The only private in class A is 10.0.0.anything. So whenever you see an IP address, you must be able to tell me whether it is a private IP address or it is a public IP address. That's another thing you need to know. The public IP addresses are what we use to browse the internet. The private IP addresses cannot go to the internet. Look at the IP address of my computer, ipconfig. My computer list, what is my IP address? Okay. My computer list 192.168. Now you know why. I am local within here. But how come I'm browsing? There's a technology called network address translation. Network address translation. It converts private IP address to public IP address so that you can browse. So I am locally now. I am having private IP address, but whoever is the gateway out or the service provider, I use Starlink right now. Starlink on their router somewhere will have a public IP address. So when I reach that router, they will say, oh, you can't go the way you are. We need to help you out. They will help me out by giving me a public IP address or putting this my packet that has a private IP address inside a public IP address, a packet of public IP address, so that I can go to the internet. And when I'm coming back, I come back with my private IP address. When I land into my house, I land with private IP address. So the only reason why people with private IP address can browse is because of a technology called network address translation. We have a chapter dedicated to this. Network address translation. Converting from what? Private IP address to public IP address. So if you don't have somebody helping you out, you can never ever go out to the internet. You can't go out. The only reason why you go out and you're going out successfully, even though you have private IP address within, is because somebody is doing that network address translation, converting your private IP address to public IP address so that you can go to the internet. And most of the time, it's your service provider. MTN, Airtel, all of these guys, they give us private IP addresses. But the only reason why we can go out to the internet through them is because on their router, they have public IP addresses and they have configured those routers to translate our private IP addresses that we are coming with, our source IP addresses, we are coming with to translate it into public IP address. That's why you're browsing. So when you build your local area network, you use private IP address. And the reason for that is to maximize public IP addresses. Guys, public IP addresses was finishing because of, am I saying doctor is there? It cannot be my side. Public IP addresses was finishing because of the explosion on the internet. So they needed to find a way to manage the public IP addresses. So they broke the addresses into two. They call some private, they call some public. It's okay. If you want to build network locally, use private. So in University of Jos, we can use 10 dots. In Covenant University, 10 dots. In another university, 10 dots. Everybody can be using 10 dots in all of these universities locally. But when we want to go out, we have few public IP addresses to help us to go to the internet. And that is how this thing works. So we have a chapter dedicated to that. And that is what this page is talking about. So we have a technology that translates private IP address to public IP address. So locally, you have private. And then when you are going out, you go with public. Take note of that. Another address I want to talk about is a loopback address. When you see an address like this that starts with 127, 127.0.0.1 all the way to this, what do we do with that? We use this to test for TCP/IP stack, or if TCP/IP is operational on our computer. So if I go to my computer and I'm ping 127.0.0.1 and I'm getting a reply, that is to tell me that my TCP is working properly. That is why if you take a look at this my table, you will see that I skip 127. Nobody asked me that question. You will see that I skip 127. I say class A is from 1 to 126. Class B is 128 to 191. What happened to 127? Because we use it for loopback testing. That is called loopback testing. Loopback testing. We use 127.0.0.1 or 2 or 3 or what have you. That's why I skip that. So we don't use it for data assign 127 on the computer and then you can begin to browse with it. No, we don't use 127 like that. 127 is used for what is it called? For loopback testing. So take note of that. 127 or 127 all the way to 127.0.0.1 all the way to 127.255.255.254. It is used for TCP/IP to test if TCP/IP is operational or for TCP/IP stack. Take note of that. Another address you need to be aware of is link local address 169.254. Anywhere you see this address, you should be concerned in your network. That means there is fire on the mountain. Why would there be fire on the mountain? Look at the range here. From 169.254.0.0.1 all the way to 169.254.255.254. When you say any IP address in this string, there is fire on the mountain. What do I mean by that? Anytime you tell your computer to obtain IP address automatically, what the computer will do is, this is your PC, it will go and look for a server called a DHCP server. We also have a chapter on this, 2 chapters actually. It will go and look for that DHCP server to get an IP address from that server. But if for some reason this DHCP server is not available, maybe it's down, the network cable is down, or whatever, the computer will just generate an IP address and give itself. That's why I think I saw it on one of my card now. It will just generate an IP address and give itself. Look at it here. When you see that 169.254, that means there is a problem. You told that computer to go and obtain IP address automatically, but the computer cannot find the server, the DHCP server, so it will give itself an IP address. That is how Windows operates. And the reason why Microsoft did this is for people that don't really know much about computer and they still want to share resources. They can just plug 2 systems together, and if they know how to share, they share resources. They don't need to know how to go and assign IP address or whatever, because the computer comes by default with obtain IP address automatically. But this is not going to work for browsing. So that address is fire on the mountain. So it is called a APIPA address. Automatic private IP addressing, APIPA address or self-assigned address. It is only when you don't have a DHCP server that the computer gives itself that IP address. And that computer can never browse the internet. So you need to go and find out why is that computer not getting IP address from your server, or you give that IP address, you give the IP address statically to your computer that the computer can use to go to the internet. Take note of that. And this is what I was saying again earlier. We have class A, we have class B, we have class C, and D, 224 to 239. This is for multicast purposes. And what about E, 240 to 255? This is used for research purposes. We don't allocate any of these to the computer. We don't use them on the network. We only use our A, we use B, we use C. And you're going to find out as you proceed. A, any IP address in class A can give you over 16 million IP addresses. Any IP address in class B can give you 65,000, and any IP address in class C can give you 254. And I'm sure you know that of C very well. When I say 192.168.1.1, 1.2, 1.3, you know that the highest number is 254. I can't use 255. It's going to be a network address. I can't use a broadcast address. I can't use 0. It's going to be a network address. So meaning the total number I can have in class C is 254. That is why we use class C for small networks. Class C IP address is always used for small network. A network of 50 computers, 100 computers, and so on and so forth. But once you begin to talk of a network of 2,000, 3,000, 5,000, 7,000, 10,000, 15,000, you can't use class C. You have to go for class B. Class B can give you 65,534 IP addresses in one family. Even though we won't do it that way, we're going to subnet it down to very close to /24, but not that too close to /24. You need to be aware of that. I think this way I'm going to wrap up the class here today. Now I talk about these public IP addresses. There are different bodies that manage these public IP addresses. In Africa, this is the body managing the public IP addresses for Africa. It's called Afrenic. They are the one that will collect this IP address from the people that share it when they share it at the center and come to Africa and say, okay, this block of addresses is for South Africa. This is for Kenya. This is for Uganda. They will share all those block of addresses. So they know the one they will give to Nigeria, the one they will give to Ghana, the one they will give to, so they will share public IP addresses to different service providers. So when those service providers are giving you internet connection, they also will now subnet those addresses and give you public IP addresses on your devices if you are going to be the one configuring so that you can go out. So there is no IP address that is given out that is new, that is strange to them. They know which one was given to which country. That is why if an attack came from a country, they know that this attack came from this IP address. Who was allocated this IP address? They go and find out, oh, this IP address was allocated to Ghana. So it means this attack is coming from Ghana. So the public IP addresses are managed by this body. We have the one for Africa, America, Asia, and so on and so forth. So you can do research, because I always forget which one is for America, which one is for Asia, and so on and so forth. But I am sure this Afrenic is the one managing the public IP addresses. So they distribute this to regional service providers. Those regional service providers will manage this, subnetting and regional, and allocate to small service provider or small service provider. From there, those service provider allocate to organizations and so on and so forth. So that is where we're going to draw the curtain today. In our next class, we're going to take it to another level.